It is time to start thinking about winter, and to get you in the mood, this is going to be my winter weather forecast for the Portland and the Willamette Valley. But first, I do need to mention a couple of disclaimers associated with this forecast. So first off, long-range forecasts are bound to have more error than daily forecasts and should be used as a guide, not a this is for sure happening. Please always be ready for any weather event that may happen, especially snowstorms, because if you've been here for more than a winter, you will know that the Willamette Valley shuts down and you get a tenth of an inch of snow on the ground. This specific presentation here is a trimmed version of the full presentation which I presented at the Winter Weather Conference this past Saturday. I am linking the full presentation slides and links to other forecasters' presentations in the description below. I'm also linking the full report for this presentation in the description. If you want to check out more opinions, please check out the other forecasters' presentations. They are all great presentations. The official totals and averages that I will be mentioning are for Portland unless otherwise specified. However, I'm making all the forecasts either A, arbitrary, B, I'll have a percent of normal associated with it, or C, I'm making it location specific, so there will be a Portland forecast and then like a central/southern valley forecast, so the forecast will apply to the entire Willamette Valley. And just as a note on what's called La Nina, you've probably heard about this in the media that this is occurring this winter, so I feel like I should address this. The rest of the meteorological oscillations are in the full report and the full presentation if you want to take a look at them. This is the cleaner slide that I had for the ENSO outlook, and ENSO is just the full oscillation name. It is an acronym for El Nino Southern Oscillation. It tracks the sea surface temperature departures in the tropical Pacific. La Nina is below normal temperatures. El Nino is above normal temperatures. The December monthly departures show that we will be in the La Nina phase, while by springtime it looks like we'll be in the probably closer towards a neutral phase of ENSO. But we don't care about spring in this forecast. We care about winter, with the exception of the water year total. So here's a comparison between weak and moderate La Ninas, because I'd say about a 50-50 shot of either occurring, and yes, there is a difference. Moderate La Ninas tend to have pretty consistent snowfall. All of the moderate La Ninas that have occurred generally have between 2 and 10 inches of snow regardless of location, median about 7 inches. For weak La Ninas, variable snowfall occurred. No years were snowless, however, though there was one with a tenth of an inch of snow, another with 2/10 of an inch. I will note that the year with the 10th of an inch of snowfall was a top analog year. Both medians were about 7 inches snowfall. With water year rainfall, the stronger the La Nina is, the more rainfall you tend to see. You have a stronger correlation in winter. There is a weaker correlation in spring as well. For temperature departure and lowest temperature, weak La Ninas tend to be a little bit cooler than moderate La Ninas. And for mountain snowpack, moderate La Ninas do tend to be better than weak La Ninas. Strong La Ninas do tend to be even better than moderate La Ninas. To look at the raw data from the analog years, this is before I make any adjustments for, okay, I like this analog year better than this one, or I think that this is just too extreme for this winter. The statistics aren't saying that this can happen, so I will be adjusting that. So this is the temperature departure from average. I do adjust all of these to each decade. And so, for instance, to take the first green dot here for my first top analog year, 1956-57. That is that temperature departure from the 1950s. So it's to counteract climate trends. So the overall median is 0 degrees from average, while the top analog median about a degree below average. water year precipitation totals, the Portland totals were about 3 inches below average, aka about 90% of average. The long-term average is 37 inches. Top analog medians were even drier, about 30.7 inches, 6 inches below average, or about 80% of normal. For the lowest winter temperatures, the median overall was at the long-term median of 20 degrees. However, the top analog median was a little bit colder at 18 degrees. These numbers are for Portland. I will note that for areas further south, like Salem, Corvallis, and Eugene, you tend to get about 3 to 5 degrees colder in a typical winter than Portland, and even more if an Arctic blast happens. So you can knock a couple of degrees off this temperature. Also, as a note, I'm not posting the statistics in this presentation. However, all the statistics I use are in the full presentation. We have broken the climate adjusted and unadjusted record for longest time above the median of 20 degrees, and I've estimated the chance of occurring again this winter at about 3%. So that is a factor I use in the forecast and is one of the adjustments I make. And for the snowfall total, and why I call this the adjusted snowfall total rather than the snowfall total. In Portland, snowfall was decreasing every decade up to right around 1970, and then afterwards, we've been having about 43 inches of snowfall per decade, plus or minus 3 inches, depending on decade. For Eugene, there's actually been a slight recovery in snowfall, with the 2010s being the snowiest decade since the 1960s. So, just as a side note, this is why some years have a lot of decimal places while other years don't. It's just because of the formula I use for that. The full formula is only in the full report. So for the overall median, it's at 5 inches for Portland. Top analog median is at 2.1 inches for Portland. As another side note, this first top analog year had more snowfall for Eugene than Portland, and the no snowfall year, there was actually 4 inches of snow that occurred for Eugene, even though none occurred in Portland. The reason why I note Eugene and Portland specifically is those are the only two spots that have official snowfall sites. Anything else that comes into the National Weather Service are from trained spotters, but they are not official observing sites. The other two top analog years were similar for both Portland and Eugene. So just based on this alone, I think the southern and central Willamette Valley have a decent shot at getting more snowfall than Portland does this winter. If you want to take a look at a deeper dive into why I chose the analog years that I chose and what the extreme events that happened in the top analog years, so I'll hint at them with my winter weather forecast after this slide. Please check out the full presentation. Also, the statistics I use are in the full presentation. But on to the official predictions. Start with the water year. A below average water year is favored anywhere from about 28 inches to 36 inches as the official total for Portland. This, for any given location in the Willamette Valley, means you'll see anywhere from about 3/4 of the average total to about average. Winter, I am thinking we will see below average rainfall. I'm just going to be brief and say below the median of 14.97 inches. My best estimate overall is about 88% of average at 33 inches. Temperatures, slightly below normal temperatures are favored, anywhere from about 2.5 degrees below average to about a degree below average. So this would be classified either below normal or near normal. I am not expecting a super cold winter, nor am I expecting a winter to be classified as above normal. My best estimate's about a degree or so below average. For windstorms, maybe a storm or two. I don't see a lot of evidence supporting a significant windstorm happening this winter that's out of the ordinary. Peak gusts anywhere from about 45 to 55 miles per hour. The lowest temperature below 20 degrees with an enhanced chance of an Arctic blast, mainly because of that statistic. Also, the top analog years supported an Arctic blast happening as they had a higher than usual frequency happening in the analog years compared to what they usually had. My best estimate is about 15 degrees. And last couple of years, I've given a most likely to be active time. I can't this year because there was no signal that was strong enough to make a prediction with that this year. So I'm just going to leave that one blank. For snowfall, mountain snow depth on April 1st, I'm thinking between 80 to 120% of normal. And then for the valley snowfall, we'll start with Portland. I'm thinking normal snowfall for Portland, anywhere from about 1 inch to 5 inches of snowfall. And for the central and southern Willamette Valley, I'm thinking slightly above normal snowfall. No historic year, but 2 to 8 inches is enough for a storm or two to have a good amount of fun. So best estimate for Portland, 3 inches. Anywhere from about 0 to 3 snowstorms with 1 inch or more, though. Again, Portland and Eugene tend to shut down with about 1/10 of an inch of snowfall. Central and southern Willamette Valley, I'm thinking 5 inches of snowfall for the best estimate. And chances of snowstorm in a bus winter are on the screen now. And that is it. So thank you for watching this. If you really want me to re-record the full presentation that I made at the Winter Weather Conference, I can post it here. However, I feel like the slides are enough in this case. So just let me know in the comments section if you want me to re-record the full one. I will be happy to do so. And then also, please stay safe out there this winter. I will post an update for this sometime in early December. I will post both a trimmed version and the full version. But otherwise, take care.